This is June 2016, paper 2PR. This is question number 7. The diagram shows a gate with a lever-operated catch. A loop on the bolt fits around the arm lever at A. This is another one of those. This is a British paper. These are very common in Britain to keep gates closed when you go through the countryside, to keep sheep, cattle in, something like that. So you may never have seen one of these before, but they just go on a gate. You pull B, that releases this bolt at A, which has got a loop at A here, and then it's got a spring so it can spring back, so you don't have to push it back into position. So we're going to describe how the lever arm is used to move the bolt. Oh, that's very easy. Lever arm moves to the left. So it's going to move to the left, and then that's going to pull on this, that's going to move it that way, and then the bolt goes out of this catch here. Suggest why the spring is needed to move it back, to return it, to return metal bar or lever to the right. So that would lock itself again. And then the lever arm operates using the principle of moments. State what the principle of moments is. So we've got clockwise moments equals anti-clockwise moments. They will accept it in the equation form, or you can accept answer in words as well, but as long as you know that clockwise equals anti-clockwise moments. The force applied at B is 22 newtons, and the pivot is 110 centimeters from B and 38 centimeters from A. Calculate the force exerted. So this is the pivot point. So if it's harder because it's upright. Normally we do ours this way, but we're going to imagine that this is this way. Okay, so this is the pivot. So this is pulling that way, and this is pulling that way. So this one is going to move it anti-clockwise, and this one is trying to move it clockwise. So it's still the principle of moments. It just so happened that the pivot was to one side. Both moments are on the right hand side of the pivot. Normally we do it either side, but nothing confusing here. We're just sort of looking for those clockwise and anti-clockwise moments. So this way we're going to say that on one side we've got the moment from B, and this side we've got the moment from A. So then we just try to use the force exerted by the spring. So F2, if we rearrange, would give us 63.7 newtons, and that's for 3 marks. Explain, 2 marks, how the force applied at B would need to change if the distance from the pivot A is increased. From the pivot to point A is increased. So if this 38 centimeters gets bigger, what would need to happen to the force that you used in order to move it? So you could say, just like the mark scheme, since distance A, that's better. Since distance A is greater, B would have to increase. Or you could say probably better, force at B. Force at B would have to increase. So yeah, that's absolutely fine. Maybe you could even use the equations down here showing that if that one goes up, this one's got to go up in order for them to still match. So if 38 gets bigger, if this doesn't move, then 22 has got to go up in order for them to still balance. And that's question number 7.